Hello, in this video we'll be doing a cross-entropy error problem. We are given some data here and we need to find the average cross-entropy error. So to get started we need to write out our cross-entropy error function because this will help us in making things clear. H of PQ is cross-entropy and that is equivalent to the sum for all x of P of x times 1 over log Q of x. So, how does this help us? Well, we need to lay out our data in a way that is easy to read and sort of think of. So let's start with a set of graphs. Now we want to do graphs here because it makes it very easy to sort of see what's going on. Now we have P and we have Q. So what do we think that each of them is? Well, in these scenarios, I believe that Q is traditionally our prediction and P is our ground truth for each sample. And so now let's make two sets of functions because we have two sets of data. And we're going to do our first set. We have a graph and it's going to look like this roughly. It goes to 0.8 and 0.2. Notice that these are our predictions. This is our prediction of 0 and this is our prediction of 1. And to match that, we have a prediction of 0. We have a ground truth of 1. You'll notice that there is a 0 and a 1 there, right? So let me explain what this data means. This means that for the x1 variable, our prediction that it is the variable 1, so maybe a better label for this would be x1. So I'm going to make one of these, I'm going to make this set of graphs for x2 as well. But for x1, we predict that the label is 1 with a 0.8% probability. However, the complement of that is that we are predicting that the label is 0 with a 0.2 probability because the probability must add up to 1 at all times. Now, on the right here, this is the actual ground truth, and you see that the truth tells us, well, yeah, it's 1. But we like to draw it as a graph because this makes it very easy to do our equation. Now, let's also do this for x2. So if we see x2, we see that the prediction is that it is 0.2 towards the ground truth of 0. So specifically, this is, 0.2 is the prediction that it is 1, is what it is. So remember in these scenarios that the prediction value is always the probability that the truth, I guess, is a 1. And so in this case, with it being 0.2, we know that it is a 1 with a 0.2 probability, and it is a 0 with a 0.8 probability. And for this data, we see that it is actually a 0, and it is in fact not a 1. So these look very, very similar to each other, and let's now apply our function. So we have the sum P of x log 1 over Q of x. Well, I see that I've made a mistake in my function up here. This is log of 1 over Q of x, not 1 over log Q of x. That would be silly. Anyways, let's go back to our function. So this is equivalent to, for every x, so let's have x equal to 0. X is a weird term to use here, but for x1 there are two possibilities, 0 and 1. And for any of these, there's two possibilities. So the possibility that 0, so we have 0 here, because the possibility of 0, and it's the ground truth of that. So we have a 0 here. So this is what we're looking at. That's a 0. and then multiply that by the log of 1 over the q of x at this point, which is this, so it's 0.2. Now we also add our next element, so the ground truth of the answer being a 1 is 1, and then the log prediction, so the log of the q of x, or the q of 1, is 0.8, so it's 1 over 0.8 here. Now, for the second one, we have, let's see, well, for the 0, we have the log ground truth of 1, and we have our log, and inside of that, we have our q of x, and our q of 0 is 0.8, so it's 1 over 0.8, and then for the next, our p of 1 is 0, and our q of 1 is 0.2. So we can see that these are actually identical to each other, right? Because these two are identical, and these two are identical. So all we can do is we can just add them up. So which equals, and because these are also 0, we can just cross them out. That's also totally fine. We can just do 2 log 1 over 0.8. And from here, it's hard to simplify. We could do 2 log 1 minus log 0.8, or just negative 2 log 0.8. That's totally fine. And this would probably be the simplest form of the answer that we can give. All right, so that was this problem for average cross entropy error. And wait a minute. And then we need to divide this, multiply this by 1/2, I believe. If I'm not wrong. Yes, that was not quite it. I forgot something. So I calculated the average here. Not the average, I calculated the cross entropy error here. I calculated the cross entropy error here, and then I added them up here. But we're trying to find the average cross entropy error, not the sum of cross entropy error. So we need to multiply this by 1 over n, which in this case, n is 2. So we multiply this by 1/2, and we get negative log 0.8. And that is the actual final answer. Okay, so this is what we're looking at. It's pretty fast, and yeah, good luck.